Taking a look at where my to-do list is now, I think I've got the shape stuff mostly where it's going to get to. I don't know if it's going to get much better than this. There will be maybe one more round of iteration on some of the ideas with the blurring stuff, but I want to set that aside and fill in some of these other features because the color stuff in particular will be an important prerequisite to getting the blending part of the blur calculations exactly right. So today I'm going to just put in the gradient. Now, the first time I did the gradient, I just did a single top to bottom gradient and I did 4 floats for each color. So it was super inefficient and didn't have a lot of features. Today I want to try to upgrade that a little bit. So I want to be able to set the gradient maybe to just be top to bottom or left to right, or I might try to do the gradient in some way where I can specify a vector that gives it a direction. I'm not quite sure yet, but I want to play around with that and also be smart about how I pack the colors this time. So let's get that done today. All right, got the color gradients from top to bottom working. I just want to quickly run through a few of the issues I hit that I was not aware of before, so you can learn from the things I just went through. First, when I'm passing a vertex attribute that's an integer, I have to use an alternate call. I don't think I've ever run into that before, or I haven't remembered that I've done it before. So when I'm passing a uint or an int vertex attribute, I have to use the vertex attrib I pointer function call. This tells it not to convert to a float and then put it into the variable, but to leave it as an actual integer and just put the integer value into the vertex attribute. The next thing I had to do is come up with some kind of plan for how I'm going to blend the samples. So up until now, as I've been doing this, I'm taking multiple samples along the vector of motion, and they were just grabbing intensity values, and so the way I was blending them together is linearly. And as I've already mentioned, I might not want to keep doing that. I might want to weight those to put them maybe more in favor of the more recent values, and so things farther back in time can be a little more faded. But it's not clear if I want to do that or not. But separately from that, there's a new problem, which is as I'm taking the samples, each sample point can have a slightly different color, or once I add in textures later, possibly a completely different color, depending on where those sample points are in the the texture it's sampling from. So I needed some kind of way for how I'm intending to blend these. And there's a couple options. One could be to do the way blending always works. So, you take the destination and you take the source and you sort of interpolate between them based on the alpha of the source, that kind of thing. But that would imply that I have to run things in a certain order. So I would, there's other ways I could think about this too in terms of accumulating the alpha. There are tricks I could do. But if I want to have it so that the most recent point in time is the last thing blended on, so that it's like 4 images stacked on top of each other with alpha blending, for instance, then I'd have to change the order of the loop so that it walks backward, like forwards in time. Currently, I actually have it walking backwards in time because the farther it goes along that vector of motion, the farther back in time it's looking. So that would be a little tricky. So what I try to do is to just come up with a way to essentially blend them all in one go, as if it's all instantaneously at the same time. And that's a little bit tricky, but since I have all the values at once, I can actually do it. Normally that'd be much harder to do than it was here, although it was still a little confusing. What I ended up having to do, that may or may not be correct, is for each sample point, I take the intensity based on the sine distance function, multiply then with the alpha from the color sample that I get back from just the gradient, and then that gives me a combined sort of alpha strength for that sample. I then add I take that and multiply it with the rest of the RGB value and add that into a color accumulator. And then at the end, I have the total alpha intensity added up and divide that by the number of samples. And I also have the total color intensity added up, and I normalize that by the total intensity sum that I had. And I think this is the right way to do it. It's a little confusing, but it did look right when I looked at the results. The math, when I tried out a couple different variants of the kinds of inputs that might have, that looked good. So I think this is right, but I need to keep this problem in mind. There might be a different way I need to blend samples. So we'll keep an eye on that. Finally, I had to do a little bit of work to get the geometry to work well with the interpolation of the gradient. I was previously taking the rectangle and modifying it by a radius, so the internal rectangle that's not sort of adjusted by the sine distance function was getting passed down. But the problem is that gave me the wrong bounds for my interpolation, which I'm using to figure out where in the gradient I want to render something. So what I've done is I went and rearranged things, so now the original rectangle gets passed down instead of the modified one, and the fragment shader is just doing the sort of shrinking of the rectangle based on the radius. And that way, when I go to do the gradient part, I still have the original rectangle, and I can base the sine distance function on the modified rectangle, and I move the computation off the CPU and put it on the GPU. I think that's just fine. That's the way a lot of the stuff is going to go. I'm going to start trying to figure out how to get things out of the CPU and onto the GPU on either the vertex shader or the fragment shader, little bits at a time while we're going through this. So that's good stuff. I think I'm going to just try to settle for adding in one more option to render the gradient from left to right instead of from top to bottom, so I have gradients in those two axis directions. I could think about something like sending down a vector and using a dot product and something like that to point the gradient in any direction. The dot product would give me a way to measure the intensity along a certain angle, but then I'd need some way to figure out how I want to express the scaling of that, so it would actually get kind of complicated, and that took enough work to just get this far that I think I'm going to cut that feature for now and just focus on the basics. So we're going to get the left to right gradient and call it a day. All right, and that's horizontal gradients. This was more of a short video getting just a new feature plugged in. The blending issue is the most interesting part, but it's not really going to pay off to think about it too much until I've got a couple other features. So next time I'm going to plug in textures. That'll be more just grinding out the OpenGL features. And once those are in place, maybe we can circle back and think a little bit more carefully about how the blend and the blurring stuff should actually work. But it's all looking pretty good, so there might not need to be a huge change even once that's in there. But it's hard to say, so join me next time. I'll work on the textures. See you then.